Application layer protocols have port numbers that identify them. For example, HTTP is identified as port 80, while Telnet is port 23. It's critical that transport layer protocols identify that number to the layers below them so that the receiving device knows where to pass that request back up to the model to get to the right application. The transport layer's main function is to identify the numbers to the application layer protocols. Any protocol running at the transport layer performs that function. It also ensures the reliability of the transmission, depending on the protocol. This means the transport layer ensures that the target host is there before you send any data. The transport layer also makes sure that the data, which has been broken into pieces, arrives in the correct order, or can be resequenced into the correct order prior to being processed. So let's look at the transport layer a little closer. Two protocols that run at the transport layer are the Transmission Control Protocol, or TCP, and the User Datagram Protocol, or UDP. The protocols running at the application layer, like HTTP, are written to support either TCP or UDP. In some cases, a protocol is written to support both, depending on what they're doing at the time. Suppose that you're using a web browser to access something on the network. The browser sends your request to the HTTP protocol, which uses port 80. HTTP was written to use TCP at the transport level, so this request gets passed down to TCP. Then, port 80 gets embedded into whatever TCP does down here. TCP is considered a connection-oriented, reliable protocol. This means that this protocol is going to take certain steps to make sure that a handshake happens with the target system and verify that it's ready to receive my data before I send it. A handshake is sort of like first sending a message saying, "Are you there? Can you receive data? Do you have this much buffer space? This is how much I'm going to send. Are you prepared to receive it?" If the answer comes back as, "Yes, I'm prepared," then TCP sends the actual data. TCP also provides acknowledgment after the fact. It requests a message from the receiver that says something like, "Yes, I did get your data. I'm ready for the next piece." TCP also provides sequencing, which means that if data arrives out of order, the receiver can look at the sequence numbers and place it back in the correct order. These are all safety mechanisms that make TCP a better choice for applications that need reliable service. UDP is a very different case. The port numbering is there. There may be an acknowledgement, but there's no handshaking ahead of time. There's no sequencing. There's no real flow control around the data. So why would you use UDP? Because it's faster. Without all that overhead, packets get where they're going faster because you're not having to prepare. You're not having to pave the way. You're not having to handshake before and after to make sure things went okay. So we could call TCP a safe protocol and UDP unsafe. TCP uses connection-oriented services, which means it performs a handshake before sending the data. The handshake is like asking, "Are you there? Are you okay? Can I send it now?" UDP doesn't do that. TCP also offers sequencing and flow control, which preserves the order and the smooth transmission and reception of data. UDP doesn't offer this. You could argue that UDP, without all that overhead, is, in certain cases, a faster overall solution, although that's arguable because if you start losing data and have to retransmit it, then it loses some of those advantages. Just to recap, the application running on the application layer dictates what protocol will be used at the transport layer. It's not up to you. Going back to our HTTP example, you can't say, "Well, today I don't care about safety, I just want the fastest browsing possible." You can't direct HTTP to use UDP. It's burnt into the application. In the case of another application, such as TFTP, which uses UDP as the transport layer protocol, it's always going to use UDP, no matter what you'd prefer. The point is, unless you're developing your own applications, the selection has already been made for you. In summary, transport layer protocols are there to take the next step after control is passed down from the application layer. Their critical function is port number identification for the application that's either sending data down the model or the application that's sending data back up to the requesting side. Then, depending on which protocol is used, either TCP or UDP, you'll get some degree of reliability over the network transmission itself.